Thank you. I was on mute. Appreciate that, Bill. All I was saying was that welcome to the first Learn with Dr. G stream of 2021. As you can see, there's a few technical kinks I'm getting out. And I'm streaming to a number of channels, Twitch, 2 different YouTube channels, and Learn TV. And so I'm going to be checking out all of the comments. Feel free to continue to comment, and I will be watching those. Today, we're going to be talking a little bit about code and software as it relates to space exploration. And we're going to, sorry, one of my things just came on. I got distracted. We're going to be talking about technology as it relates to space exploration. And then we're going to do an intro level dive into Python using Visual Studio Code and the Jupyter experience there. All right. I'm going to, hello, Happy New Year to you too. All right. Perfect. Just checking out other things. Okay, great. What is it like to work in space? Am I a sci-fi fan? I am totally a sci-fi fan, definitely. I don't know personally what it's like to work in space, but we do have a module or some like learning paths, learn modules that we're going to explore today. That I wrote based off of conversations that I did get to have with folks who actually work at NASA. So I'm really excited to talk about them today. Before we continue, though, I did want to remind everyone that we do have a code of conduct here at Microsoft. It applies to live streams, events, in-person things, etc. Basically, all it's saying is be kind to each other, be kind to me, I will be kind to you. We're just here to explore and learn and chat and be together for the next 45 or so minutes. So let's do that together. We are going to be using Visual Studio Code, so I'm going to talk a little bit about space exploration and the technology that might be interesting behind it. While I'm doing that, if you want to download Visual Studio Code, I highly recommend downloading the coding pack for Python, which will include not only VS Code, but also the Python extension and Python and the Jupyter environment, everything that you will need. If not, you can actually download all of those extensions. You just go into the extension library and type in Python and you should find everything. If you want to check that out, this right here, and bear with me as I try to post this everywhere. We do have aka.ms/learn on VS Code, and I do have that for the comments as well. That you can go to and you can find this page. All right. So as promised, this is the NASA-inspired or space exploration-inspired learning path that we're going to be talking about today. You can find this learning path at this AKA link, aka.ms/learnwithdrg/Python in space 11. It's in the comments and on the screen. And awesome. This is one of our more popular intro to Python or intro to coding learning paths that we have on Microsoft Learn. And I think part of that is because what I was trying to do here is really talk about technology and code as it relates to an actual application like space exploration. I don't know about you, but I am a huge fan of things space related. Back in college, I got the opportunity to do a research internship with NASA, the Jet Propulsion Lab, Nasa Jpl. It's down in California in the United States. And we got to build this simple little application where we took images that the Mars rover took from being on Mars and brought back to Earth. And we built this little game for kids to tag what they saw in the images. Like, do they see a shadow of the rover or the rover itself? Do they see rocks? Do they see a horizon? Do they see whatever? The reason is that these images are actually categorized by scientists and researchers to like a much finer detail. And so our goal was to see if we could have kids look at real pictures from the Mars rover and help like pre-categorize things. It was just a research project. It didn't go out like fully into the world, but we did test it out with some kids and it was a lot of fun. That was one of my first kind of hands-on experiences with how code and software and applications can be used to help further the research and the science done related to space exploration. It's not just what's happening, on the rocket or when you get to the moon or to Mars. It is also what happens when you bring things back here on Earth. So I thought that was really neat. As part of that, we got to visit NASA Jpl, and it was really, really, really interesting because back then, this was maybe a decade ago, the time that it takes to send one command from Earth to the rover on Mars was something like 15 hours or something like that. So, and then the time it takes for the rover to kind of send information back was the same. So it would take a full day to kind of get information to and from the rover. And that's tricky. Like they did, there's a question, could I also use machine learning, image classifiers, TensorFlow? Yes, nowadays you could. Back then, they weren't a thing or not widely available. So, but yes, that's a great question that James asked about using machine learning image classifiers to classify them. That would be a much better approach today. But yeah, so it would take a full day, a full 24 hours, 30 hours, something like that, to kind of send a command up and back and then get the information back. And the reason why this is particularly important, the rover knew how to kind of navigate along Mars and the moon on its own. But the reason it was particularly important is because this rover got stuck. And the scientists and the researchers here on Earth needed to help this rover get unstuck. It got stuck to a point where it couldn't get itself unstuck. And so it had it first kind of take pictures around itself and send those down to Earth. And then it was like, okay, let's, do we really want to, I mean, I don't know about you, but if you've ever played with like a toy robot with like a controller or a toy car or boat or anything that has like a controller, a wireless controller here and then there, and it's like a physical thing, oh my gosh, it is so hard to get it right. Like sometimes you accidentally go left instead of right, just silly things like that. Now imagine taking a full round trip day to like send one simple command and then see if it worked. That would just take way too long. So what they did was they created, after having the rover take a bunch of pictures, they recreated the rover and its environment down here on Earth so that that way they can like quickly test what would be the most efficient way to get the rover out of that stuckness. And then they had a clear set of instructions that they could send one by one and feel fairly confident that it would get out. They still waited for kind of responses to make sure they didn't make it worse. But that was just so cool to think about how, it's not just the code you write, it's not just the application, it's not just the technology behind it, but also the problem solving skills and the way that you have to rethink how to solve problems given these, unworldly, literally, constraints and challenges. I just thought that was so cool. So I don't know, I absolutely fell in love with it. If you want to share why you love space, if you do love space and exploration in the comments, feel free to, because that's part of what today is about. It's just kind of sharing and exploring. So a couple of things that I wanted to mention before we jump into the introduction to code is one thing in particular is the Artemis mission. And I don't know if you have heard about it yet, but the Artemis mission, we describe it a little bit in this introduction to Python for space exploration module. That's part of that learning path that's on the screen right now. But the Artemis mission is NASA's lunar exploration program that will send the next man and the first woman to land on the moon by 2024. And the reason why this is important is because the goal of this is not just to land on the moon, which is already going to be exciting, but also to prepare to figure out how we could then send humans to Mars. So part of this whole program, if you read into it, it's about how do we send enough equipment and enough fuel and all of that to not only send people to the moon and back, but also to send people to Mars and back. Can we make like a pit stop on the moon and leave some stuff there and then, continue on? Like what needs to happen in order to make that possible? Yes, the first woman and the next man. I actually wrote it that way in there, but yes. And I think that's just so neat. Space exploration equals hope. I agree with that one. That's part of what inspires me to kind of use this as like a scenario, is that it inspires this beyondness. Like what can you do beyond what we thought we could do, beyond limits that we thought were there. And that's what this Artemis mission is about. It's about, we know we can make it to the moon, right? As in like, we've done that. It's still so exciting. And I still think it's like so cool, but we know we can do that. So how do we push the limits beyond that? It's not just build a bigger rocket with more fuel and go all the way to Mars. It's how do we, use the resources intelligently and resourcefully and kind of go that next step. At least that's how I see it. So the Artemis mission is particularly interesting. And in this unit, we actually have, how many is it? 6 different like key systems that are required for exploring the moon with the goal of eventually making it to Mars. And this is where, if you are interested in, going into the industry of space exploration or interested in just kind of solving these types of problems, this would be a great list of a place to start to figure out where you might want to learn more and kind of develop those skills so that you can be a part of this like incredible journey. One of them is ground systems. So basically, like, how do we make sure that whatever we build to kind of shoot up into the sky can sustain shooting that up into the sky? And I think that like, again, it's not just about like the individual rocket. It's also about keeping the people here on Earth safe, like making sure that they can actually launch all of those types of things. So the ground systems, everything that entails, that's a huge, huge, huge gap. Or not gap, but kind of opportunity. The space launch system. So again, we've launched to the International Space Station. We've launched to just kind of into space. We've launched to the moon. But how do we design a space launch system that can launch to other destinations as well? That can be flexible and evolvable so that we don't have to rewrite something for every new destination that we want to go to. Someone was commenting about that JavaScript might make more sense as a more complete general language. I am very, 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 very much out of the narrative of which language is better. My point of view is that you choose the language that is best for that day, like that time, for the resources that are available to you and the problem that you're trying to solve. So if the problem that you're trying to solve with JavaScript is better than with Python, then definitely 100% use JavaScript. I am doing Python right now because I find that the resources available for learning data science and machine learning are just really strong around Python at the moment. And you can do quite a bit without a ton of learning curve. So that's why I like to focus on it. But yeah, I completely agree. JavaScript is another really great language, and I'm sure we could have a full-on argument about which ones are better. But I think it's mostly kind of to each their own. At 49, you will see a manned mission to Mars in my lifetime. Yeah, and so they call them, nowadays, they call them, oh gosh, crewed missions, which I just learned. But yes, so a crewed mission to Mars, I don't know. I mean, I'm hoping, if we're getting to the moon again in 2024, I'm hoping that means that Mars isn't too far off, right? I mean, hopefully. So yeah, I think so. And then manual data annotation tool without touching JavaScript. I don't know about building a manual data annotation tool without touching JavaScript? I mean, I'm sure you can, but I think it'll totally depend on all of the things. What do I think about Julia? I don't know if I know Julia. Yeah, we should put our optimism cap on for if we can make it to 2024. I'm hoping so. All right. Orion is the new spacecraft that they're developing. And this is really cool. I actually talked about this in one of my other shows where we were building basically, it wasn't a machine learning model technically. I mean, it was fairly simplified, but we were using data based off of the Apollo missions to predict how many rock samples the Artemis missions would be able to bring back. And we partly did that by examining the spacecrafts. And the spacecrafts are really interesting when they go to the moon because there are a few different kind of layers to it. There's the actual like rocket part. There's the orbiter, like the lunar orbit part, which just basically orbits the moon. And then there's the lander, and the lander has to like leave the lunar orbiter. I'm probably not using the exact right terms, land onto the moon or to Mars, and then be able to come back and then bring everyone back safely. So again, what does that look like? Like, how can we design them better? How can we design them efficiently? I found out that for the lander, the material that separates the astronaut from space is like almost as thin as foil. Like it's mind blowing. So there's a lot of really interesting things there. The gateway, which is again, that communication between the astronauts on the moon and the people on Earth, or the rovers on the moon or on Mars or whatever. It might be how we can go farther, like to Mars versus just the moon, make that communication faster, more efficient, send more data at one time, etc. The human landing systems. So this is those lunar landers. So not just the orbiter, but also the lander that kind of goes back and forth, and making sure that you can go back and forth effectively. And not just be able to land, get off, collect, and come, but also land and stay for a while, right? Like land and do some research and exploration and stay for a while. And then, of course, the spacesuits. There was actually this competition for, I think it was high school students, on designing new spacesuits. But the spacesuits themselves, helping them last longer, be more flexible, just like tons of information. Okay, I'm going to check over on the comments again. I think that the Python creator joining Microsoft is pretty cool. I don't know. I think it's pretty cool. Why not having a launch pad on the moon to launch to Mars instead of launching to Earth to Mars? Yeah, I think that's a great idea. And I think that's exactly the type of thing that they're exploring now, right? Like, can they send enough equipment? Because as you can see, like the ground systems to be able to launch a spacecraft from Earth into space, just into space, is already pretty complex and requires a lot, just a lot, right? And then you have to think about kind of the gateway, right? The communication between the moon and Earth. So are you sending enough people to the moon to be on like a ground system on the moon and be able to communicate with people launching from there? Or is it kind of doing a ping or coming all the way back? Like, but yes, I think that's exactly the type of thing that they're thinking about, is like, can we make that moon kind of a pit stop? I think that's a really great way of thinking about it. I don't know if that's true. I do not work for NASA. I'm not a rocket scientist, but cool. So it seems like JavaScript has recently released a library called, I'm not going to pronounce this probably right, but danfo.js, and it's like pandas, it's like pandas in Python, but for JavaScript. That is awesome. See, that's the kind of thing that I'm so excited about as languages evolve and we get more resources for them. It's interesting to think about that we're closer to find Earth 2.0 one line of code at a time, right? I know, I like maybe optimistic for what we're going to do today, but I completely agree. I think that that's exactly why we're exploring kind of like what are the problems at hand and what can code do, right? And even if code is only solving a tiny piece of that, that tiny piece is one less piece that we need to kind of think about for the entire thing. And what software am I using to stream across multiple platforms? I'm actually using StreamYard. So that allows me to stream to multiple places and also allows me to have all of the comments in one place. So that's really, really handy. All right, if you are just joining us, the Learn module that we are exploring is this one. It's on the screen, but I'm going to paste it in the comments as well. And yeah, we're going to be jumping into some Visual Studio Code here in a second. So you can check that out on Learn on VS Code. And today, like I mentioned, we're just going to be doing a very brief introduction to using Python in Visual Studio Code with Jupyter Notebooks. In future episodes this month, I will be doing some additional work around discovering like how we can use code inside of space exploration. In particular, we will be jumping into some of these other learning paths. One of them is classifying space rocks using Python and artificial intelligence. And then the other one is predicting rocket launch delays with machine learning. But today we're just going to do a brief intro into Python. Before we get started, I did want to share this really cool thing. It's linked to from inside of the module as well. But I just found this as I was exploring. And this is basically NASA's open source projects that they have related to space exploration, which again, I just think is so neat. So if you go to this site, you'll just find the 571 NASA open source software projects. And each one is different. This one is a software framework for control and observation in distributed environments. We have a mission simulation toolkit. I mean, there's just like a ton of different things, lots of different languages, lots of different applications, lots of different goals. Some of them are using things like AI and machine learning. Some of them are like just kind of building things. So yeah, you should check this out if you're interested in space exploration and how technology plays a role, because there's just like 571 projects that you can check out. Yeah, I've been wanting to just like jump into some of these and like explore them, but it's pretty cool. All right, awesome. So I think now what we will do is we're gonna head over into Visual Studio Code. And what I've done so far is installed the Python extension pack. And so over in my extensions, I basically have, let me just search because I have a lot of extensions, but I have the Microsoft Python extension, which if you already have Python installed, which you will need to, it has the link here, then it allows you to like write Python as you normally would, but it also brings in the Jupyter Notebook experience, which I particularly love, especially when I'm exploring code for the first time and just kind of like getting ideas out there, not necessarily building one thing, particularly for data science and machine learning. This is what the Jupyter Notebook experience looks like. If you're used to, this is, all this code will be up on the web afterwards, by the way. If you're used to a normal kind of, you know, or normal, if you're used to like a .py file, then you're used to Python just kind of being in a file with line numbers, etc. And then you run the whole file and things happen. Jupyter Notebooks are slightly different in that each cell can be run individually. And the nice thing about that, particularly when you're dealing with data science, is that you are going to be exploring some data. And maybe you kind of like try to slice your data in one way, shape, or form, and you realize, oh, that's not what I wanted to do. You can actually like rerun a previous cell and kind of refresh it instead of having to rerun the whole program. You can see different parts like you can kind of scroll up and see different things at different points. You can change one thing at the top and just rerun all of the cells. There's just a lot of kind of flexibility here. Nice to see you too. Thanks. I'm glad that energy is coming across. So I really love Jupyter Notebooks. It's just my favorite way to explore data. And I just wanted to kind of give you an intro into how you can write Python with these notebooks. So a couple of things here at the top. I know it's probably a little hard to see. I'm going to zoom in a bit just while we're doing this. Here at the top, you'll see that we've got these different types of buttons that do different things. Typically, the one that you're going to be wanting to think about is the one related to this particular cell. So one really neat thing is that we can Python to explore space. We can actually just write it in my Markdown. So I clicked on this little Markdown button and it changed my cell to a Markdown cell, or I can click on that code button and it'll change it back to code. I could have also, just done a comment. That's just a comment. And if I run the cell, nothing happens because it's just a comment. If you did Markdown, you can always edit it again by double clicking. But there isn't this kind of bracket with a number next to it because this isn't a cell that you can run or execute. I mean, I guess technically you're kind of executing the Markdown cell, but it's just a Markdown language. So you're just displaying something. This is a Python cell that you would actually run. If the cell hasn't been run yet, it's got this dash in it. If it has been run, it's got a number in it. And the number, it corresponds to what order they've been run in. This is important because, like I said, if you're kind of going through and you're writing a lot of code and then you realize, oh, this one doesn't really make sense, and it's because I set this variable to be higher than it should have been, you can go back, change that variable, and then run these again. But you don't want to skip the ones in between, so you want to make sure that it's kind of in order. Last time I checked, Python 3.9 was incompatible with NumPy. I'm not positive about that, but I do use 3.8. I have not actually checked with 3.9 yet. I just know 3.8 works. So that may be true. All right. So the neat thing about Jupyter Notebooks is that, I mean, you can just run it like a REPL, right? So you can just 2 + 5, and that'll give us 7. The output comes down here. You can also do things simply like print. Hello. And then it'll print hello. Yeah, fairly simple. If you needed to kind of like erase it all. So one thing that sometimes you'll want to do is, let's say you had this really big notebook and you're printing a bunch of like big charts and graphs or tables or whatever they might be. You might want to clear out all of your output. This button right here with the cells and then the X, that clears out output. So if we look at it kind of zoomed out, we can see we have output here and here. So we can click on that, clear all output, and it just kind of gets rid of it. And because we no longer have output, all of the cells are back to where they were. You can also just run the current cell and every cell below it. So again, if let's say you needed to just change one thing that's like kind of in the middle of your notebook, you can kind of just run everything below it. Or you could run everything above the current cell. So you notice that this one didn't get rerun. That's still 4. Or you could run all of the cells. Again, they're updating because we haven't stopped the kernel. So this is 7, 8, and 9 now because the kernel is still running. So everything that we did before is still kind of in that working memory. If you did want to stop it, you can stop it here, or you can just kind of start it. Usually what I like to do is, if I'm like wanting to be perfectly sure that everything is going fine, I usually interrupt my kernel. Then I clear my output, and then I restart my kernel, and then I just make sure that it's back to 1. So it looks like we're good. All right. VS Notebook is missing the famous button to delete the content generated in the cell. To delete the content generated in the cell. I'm not sure the bot generated content. I don't know what the content generated in the cell means. You can delete the output, or you can delete kind of the entire cell. But so far, I have not found that there's a ton lacking for the purposes that I have. You can also do this run line by line. So if you have multiple lines in a cell, you can run one at a time. And then you can also gather the code required to generate this particular cell into a new notebook. These are all advanced features that we're not going to get into today. Yes, to delete the output, you just have to click on this clear all output. If you want to actually kind of flush it from your memory, then you want to interrupt the kernel and flush it out. All right. So those are some like super basics. Let's get into a couple of other basics. Number one, and for those of you who are, super advanced or just have done this before, feel free to continue to comment and answer as I ask questions. If you're brand new to Python or to using notebooks or to coding in general, that's awesome. You are 100% welcome. This is also for you. And so feel free to guess. Again, this is a friendly community. We're here to learn. So if you already know it, that is awesome. And I'm so happy that you're here. And please help contribute in the comments. And if you don't know it yet, try to guess, because that's how we learn. So for example, one thing that is very important, especially if you're sending humans out into outer space, is being very specific with your numbers. So if I were to do something like this, no, let's do something like this. What do you think would happen? What is my output going to be? 100 divided by 6. This gets into the language Python and what assumptions it makes. But that's part of learning to code for the purposes of doing something that's very specific, like sending humans into space, is making sure that you understand the assumptions or the decisions that the people who created the language and or the environment and platform made when they did so. So if you're unsure, you should always test things out. If you're doing 100 divided by 6, it is going to do a float output that's just kind of this like trailing 6s here. Oh, okay. So the ability to delete the output for one particular cell, not delete the output for all of the cells, is the question. And you're right, I don't think that we have that functionality yet, but I do know that things like being able to run a cell line by line is newer, and that this is actively being worked on and improved. So that's a really great piece of feedback, to be able to erase just the output for one particular cell, and we can pass that along to the team as basically a feature request. Yeah, so we can see that we get even though we sent in some like whole numbers, some integers, we do get this float type back. It doesn't truncate or take off the decimal. It shows it there. Other things that you want to test out whenever you're playing with a new language or experimenting is something like this. So order of operations, what we assume will happen versus what will happen. You might have seen these types of things on the internet. They pop up every once in a while, like, which one is it? Is it 10 or 4? And, people are arguing in the comments, and then someone plugs it into a calculator and someone plugs it into another calculator, and they give different answers. And that's because the software and or the programming language is using different rules to determine like the order of operations. So knowing what they are ahead of time is important. For example, if we were to do this, 2 + 5 × 3, what I would assume would happen is 5 × 3 first, so 15 + 2, 17, which is true. My advice, anytime you're doing any kind of coding, is to just make sure, first of all, like run your assumptions, but also just make sure that whatever you're doing can't be interpreted another way. So I would always recommend to do something like this, if that was your intention. Then that way there's just no confusion and we know that you wanted to multiply before you add. Why isn't it 16.66667 at the end? That is actually a good question. I noticed that and then I got distracted by comments. I don't know. If anybody knows in the comments why this is like trailing sixes with an 8 versus trailing sixes with a 7, I'd really, really like to know. I feel like, I don't know. Yeah, I have no clue. Because then why wouldn't it be like 9? Like, why 8? 8 seems just like such a random number. I really don't know. That's a great question. All right, let me also just change this over. Cool. So, and of course you can, you know, like take advantage of order of operations further and do something like 2 plus 5 times 3. Another thing that you want to pay attention to when you're learning a new language and you're, you know, doing something in a new type of environment like a notebook is whether or not the spacing or tabbing matters. So, for example, can you do that, you know, versus this versus this? Spaces don't typically matter, of course, unless you're doing something like variables, which we'll show you in just a second. But in Python, tabs do matter. So if you do have a loop, which we'll get into in just a minute, or like a function or something like that, then tabs are what matters. But just some things to kind of look out for. Does it look like a bug? I'm going to ask about it. I am going to ask about that 6668 because I don't know. It is worrisome. Like I feel like maybe there's a bug, but also I feel like there might be a reason. I don't know. Am I working in dev secret project? I don't know. Like maybe there's something. I don't know. All right. Cool. So a couple of other things that if you're new to coding, you may not know about. This one is a lot of fun. This is called the Modulus Operator, mod for short, and you show it using a % sign. So 10 mod 3, basically what it's doing is it's dividing, and then the output, the answer, is going to be the remainder. So 10 divided by 3 is 3, remainder 1. So the output of this would be 1. Again, experimenting with these things is always a good idea. Another thing that is useful is the exponent or exponential operator. So for example, the moon is 5 to the 5.37 power miles away. I don't know how to say that. 5 to the 5.37th power. I feel like that's wrong. So the moon is 234,422.88 blah, 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 blah miles away. It has to be a rounding thing, right? I feel like it has to be a rounding thing, but I don't fully understand it. We will figure it out. I'm going to find out the answer and then I will post it on Twitter. I'm at Dr. Guffels or hashtag learn with Dr. G. So if you want to know as badly as I do, I will find out and I will post this on Twitter because I want to know why this is like 0.888. All right, let me, the last printed number is higher when the first, what does the not printed is higher than 5? Yeah, but then wouldn't it be 6667, not 6668? I don't know. Iron Python 3. I don't know anything about the project Iron Python 3. Now I'm curious what it is. I'm going to have to look that up. But no, I do not know anything about the project Iron Python 3. Also, hola, Jorge. All right. The last operator that I did want to mention was 5-2. So knowing what we know above with the modulus and the exponential operators, what do we think would happen here? I'll give you a second to guess. Import decimal 100. Yeah, but why? But then why isn't, hello, Naeem. So why is it not 6.8? Is it like a float thing versus a decimal thing? I don't know. I'm so curious. So what this does is basically the opposite of modulus. It gives you the whole number after a division. So if you wanted to know, for example, we had 5 rocks and we needed to divide them into 2 containers, and each rock could only contain 2 containers, or sorry, how many whole rocks? No, sorry. We had 5 rocks and we can only fit 2 rocks in each container. How many containers can have rocks fill it? I can't even say that sentence. Basically 2, right? We're trying to get to no remainders. What would we have to leave behind? All right. Creating variables. Again, if you're new to coding, this might be something that feels new, but you have done it in math before. So for example, we can have a variable called number of rocks. And in Python, we don't need to have a semicolon. We don't need to have a type. The type is inferred based off of the data that you have. So number of rocks is 5. We could have the temperature in space be negative 457.8. So this would be an integer is number of rocks. Temp in space is going to be a float. You could have a string like rover name. Or you can have what's called a Boolean value, which is either true or false. So rocket on would be a Boolean value. This doesn't do anything other than create these variables for us that we could then use. So for example, I could then say print rover name, and this would print Artemis rover. With notebooks, another thing that is interesting is that you can print out the value of a variable. So here we were calling the print function, which sends that variable to the print function and then prints out our string. But we can also just get the value of a variable. So for example, the value of rover name is the string Artemis rover, which contains the quotes. And the value of rocket on is the Boolean value false. Yes, integer division. That was the double slash. Another thing that you can do, if you follow along in the next couple of ones that we're going to do, we're going to be talking about different types of rocks. One type of rock that we collect from the moon is called a basalt. So we can create a variable called basalt rock count. And we can do something where every single time an astronaut or a rover picks up a basalt rock, we can add to it. So basically, rock count equals basalt rock count plus 1. And then if we were to print out basalt rock count again, now we would have 1. Another thing that you can do is just do a plus equals, which is kind of like shorthand to say I want to take this value and I want to add this number to it and then save it back in that value. So now it's going to be 2. Yes, you can specify types if you wanted to, but declaring variables with lowercase and then uppercase is a variable name convention. Oh, I'm going to get in trouble for this one. I can never remember. Different languages and different like groups of people have different preferences for these types of things. I prefer this, and it's camel case, like lowercase and then uppercase next ones. That's what I prefer for variables, regardless of the language I'm using. Oh, don't hate me. That's just what I prefer to do. I feel like it makes more sense to me as a human. But I also, if I am contributing to someone else's project or to a larger code base, I will follow whatever standards they have for that. Okay. So you can basically do kind of like a bunch of different types of math by using variables instead of the numbers. Another thing that you can do is do some string manipulation. So for example, we can have this variable called astronaut with a value Remy Morris, which is a string. And then we can do something like, say, I want this entire string to move to uppercase. Notice here, though, astronaut variable still has the value Remy Morris without the uppercases. So the upper function returns a new string with all uppercases, but doesn't actually manipulate that variable's data. This is important in Python. Different things have different effects. So especially when you start to introduce new libraries like Pandas or NumPy, it's very important that you look at what is going to affect your data and that you don't make the assumption that it is replacing it or saving it or not, that you kind of make sure you know what's going on. Again, this is also a really useful reason why I like to use notebooks when I'm doing this type of data manipulation and exploration, because if I did make the assumption like this, nothing would have happened. It wouldn't have gone upper. It wouldn't have gone to uppercase. And if that was like hidden in like line, 21 of 59, it might have been harder to find. But because I can see it right now, then I can kind of replay it and fix it now. Okay. Awesome. Let's see. I know, I love camel case. It's like my favorite. Lowercase and uppercase. Is floating point arithmetic error when converting to decimal that yields the correct answer? This is so cool. I need to like go explore this more. Okay. Another really fun thing that you can do with strings, and I'll let you explore these inside of the module itself, but you can have one that is completely wonky in terms of the capitalization and then just capitalize it. And then notice here, if I were to print out rocket output, it is still wonky capitalization. That's because we did not save it into a new variable. This was just printing out the output of the last line. So for example, if you do this, it would still print out wonky because the output of the last line is the variable where we didn't actually change it. And the only way to change it for real would be like this. All right. Another really important thing in Python and particularly in data is lists. So you can create lists of pretty much anything. This is, for example, a list of strings. And you can also do a list of multiple types. So this is a list that contains strings, integers, and floats. There's a bunch of stuff that you can do with lists, like append items to the lists. You can pop items to the list. I'll let you explore lists on your own, but basically they are just a list of data that you can then manipulate the list for. Yes, Jupyter with VS Code. It is my favorite thing ever. Do I work at or with NASA? I do not. I work at Microsoft, but I do partner with NASA on various projects like building this content. Regular expressions are fun in Python. I agree. Imagine doing this in Pascal. Oh yeah, that would be fun. Let's do that. No hate to Pascal. Other things that you can do, for example, with lists is you can specifically call out one item in the list and change it. So right now our list is basalt, highland, and breccia. This is 0 base, so 0, 1, and 2. So we're going to change breccia to soil. The next thing that I just wanted to show you briefly before we end, because now we're already getting towards the end, is being able to do some like code comparisons. So most programming languages have all of these. They all are going to appear differently though. These are our Boolean comparison or Boolean expressions. So for example, if we had a variable called temp that was 50 degrees, then we would want to print temp greater than or equal to 32. This returns a Boolean value. True or false is temp greater than or equal to 32. And this is temp less than 32. Greater than or equal to is going to include the number 32. Less than will not include the number 32. strictly less than, inclusive, things like that. So those are going to print out the Boolean values that they evaluate to. What department am I graduated from? I have all of my degrees in computer science. What chat is I reading? I am reading all of the chats. How do I make a cookie logger? I do not know. VS Notebooks is that it takes advantage of the potential of your laptop. Yes, I love it too. But it also has a bunch of other features that I also love, like live share. All right. Another type of Boolean expression in terms of comparisons are being able to compare equality. So for example, if rock was basalt and we wanted to compare it using equals equals, again, other languages, you're going to use different types of comparison ways to compare depending on the type. In this case, we can do it. I'm thinking back to like Java, I had to use like dot equals instead of equals equals if it was a string, because a string is an object. Going on a tangent, but there's a lot of different types of comparisons that you can do. And with these comparisons, you can then do things called control statements. This is often known as like an if then else, but doesn't have to be exclusively that. So for example, if we had a variable called basalt that was 0, and we say if basalt equals 0, then I want you to print this, no matter what, print this. So this is where those word tabs come in handy, because the tab indicates that this line right here is a part of the if statement. This line is not. So both are going to print. If we were to change this to 1, only the last one would print, because this condition is false, so we do not enter it. IoT and ML in agriculture, that is a great thing. There is going to be more content around that. I've seen some projects happening, and so you should definitely stay tuned around IoT and ML in agriculture. We can also then go into an if. So this is kind of like an if statement, right? If this, then this, else this. So if you wanted to say we found no basalt rocks, if it equals 0, then you could print this. Otherwise, you could say we found some. And if we changed basalt to 1, then instead it would say we found some. No matter what, it says done checking. Notice that with ifs and elses, you do have to have this colon at the end of it, and then you do have to have the tab to indicate that you that is a part of that condition. All right. The last thing I want to show you before we're kind of headed out is if, elif, else. So this is where you might have multiple conditions. If you have no basalt rocks, we found none. Else, if you have 1, then we found exactly 1. Else, print, we found more than 1. The reason why this can be useful, you wouldn't want to do it for every single number probably, but the reason why this can be useful is that instead of just having like if, is that if this one is true, it won't even check the rest of them. It just skips over the rest of them, because this is an if then else statement. It's a condition that's kind of all together. And so it checks this one. If it's true, we know that the rest will not be true. If it checks this one and it's false, and then it checks this one and it's true, we know that the rest will not be true, so it can skip the else. So the only time it ever even goes into the else is if both of the other ones were false. This is important to note, because sometimes you do want it to check multiple things, because just because one is true doesn't mean the other ones aren't. In that case, you just want to have it be a separate if statement. All right. I feel like this time always goes by so quickly. Is the colon from Python or just Notebook? Oh, good question. I'm 99.9% sure it is Python, not just Notebook. How do I do that in Visual Studio Code? I mean, expand and hide. The expand and hide. I don't know the expand and hide. I'm not expanding and hiding. I'm just scrolling. Sorry. I don't know Any recommendations on when to get some cool data sets for space exploration projects? That's a great question. I would say you should try checking out the NASA open source stuff, because I bet those projects have some data sets. And then, yeah, I guess there's someone else mentioned a NASA API. Here we go. Oh, nice. Awesome. 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 There you go. Very cool. I'm going to put this on the screen as well, and make sure that I share it over here also. And we're pretty much out of time. So one thing that I did want to ask is if you could please fill out this survey. This survey helps us to make sure that the content that we're presenting to you all is content that you want to see and hear and participate in. So I highly encourage you to take it. It should only take just a couple of seconds. As always, feel free to reach out to me at Dr. Guthel's #LearnWithDrG on Twitter. And I'm going to for sure find out that 666666668 thing. I think we figured it out in the comments, but I'm definitely going to check it out. So yeah, thank you so much for joining me. And I cannot wait to see you all again, actually this Thursday at 1 p.m. Pacific time for a special version of Learn with Dr. G. Thanks, everyone. Bye.